Hello everyone, this is Anil and you are watching the YouTube channel Nilkamal Classes. So I welcome you all in my YouTube channel, and if you are new on this channel, then I request you to subscribe the channel, like the video, give your comment and share this video with your friends if possible. So now we are studying Lagrangian dynamics. In Lagrangian dynamics, we have studied constraints, classification of constraints, and in last class we made some more formula for holonomic plus Lagrangian. And what was that formula? We have drawn applied minus dr dot dr is equal to 0. This formula we have seen. So here one term was there first of constant, but it got disappeared. So for now in this formula we need no need to worry about that force of constant. If any force of constant is there for holonomic plus scleronomic. If you have any force of constant, we no need to worry. We have to see the for applied force and displacement, and according to that we can solve it easily. But last class also I told you, if we say that rheonomic for holonomic plus rheonomic system, then we could not remove that term. That force of constant which make, then we have formula like that. Applied force plus force of constant, and we had like this is equal to 0. And if we took the dr, then the angle between force of constant and dr is not equal to 0, was not equal to 0. We did not get 90 degree angle, so we could not remove, and our means this type of easy equation we did not get. So our main aim is, or purpose is, however we want to remove this term, and for this term, removing this term, there is only one way. What is that? If we make angle 90 degree between the displacement and force of constant, then it is possible, because automatically because of 90 degree angle it will get disappear. So how to do? For that we will introduce new term, and what is that? We will then equation like, let me write it again, x square plus y square and r square, which is depending on time. So this equation is depending on time. Because of that, the length was getting short. For this example, if I take this example, and here 40 times is like this. So it was getting short according to time. So how to make? So this angle is not equal to 90 degree. So how can I make 90 degree angle? For that one, if I make become possible, or if I make that length is equal to constant, or this one is if I see that L and T is not dependent on time, or not dependent time, or constant, if I make it like constant, then it is possible. So how can L is depending on time? What if I make T is equal to 0 and make some displacement? This is not possible for a real system, but in theoretical we can change it like this. So if you will see reality, it won't possible, because if anything is happening, so for this ones we require some time. So with constant time t, we cannot change the position of a particle, but virtually we can do. Virtually in the sense, theoretically we can change it. And how can we change? I will take that in this equation only. This is my equation, square plus y square is equal to L of t, and L is dependent on time, and t I made 0, delta t is equal to delta t is equal to 0. So now delta t is equal to 0. So time is not changing. If time is not changing, then L is constant, or I can write like this, in this way. So this is equation, and if you see this equation, this is a circular path, equation of a circular path, and if you take consider radius. So this is a part of like this, and this is length. So this displacement, any time we take, so this displacement is perpendicular to the DRL. So both are perpendicular to each other. So both, if they are both are perpendicular, then angle is 90 degree. If the angle is 90 degree, our equation gets solved. If I take dr here, dr here. So if I take it out, and it will be like this. C force of constant dot dr, and this is dot product. If I remove it, so dr cos theta 0, and if theta is 90 degrees, so it will give 0. Sorry, let me read. This is like this, and then if I cos theta, cos 90 is 0, so it will get 0. So our problem gets solved. So if practically we are not doing it, theoretically, so don't think that how it is possible. It is not possible in reality. Experimentally, it's not possible. But theoretically, that's why we are giving that way it is will give then a virtual displacement. Here, that time till now I was writing dr, but now I will replace it some method, because there should be some difference between this is dr and virtual displacement. This was real displacement. If I take, then I will replace this. Then you make it, and with that, this is virtual displacement. What is virtual displacement? Any at a constant time t, we can take a smaller change, little bit, very small change, means too much more. If any particle pendulum like this, I will take this much more. So we are considering that at time t constant, there is a smaller displacement, and that is small because of smaller displacement. Time is constant, so angle is between them 90 degree. If angle is 90 degree, then both are perpendicular. If both are perpendicular, then the force, because of force and displacement, angle is 90 degree, so work done will be 0. So this term will be get cancelled and equal to, and if I take this one sigma here, again I do sigma, so it will be like this. Applied force minus E dot, and I will take it out. So del R plus force of constant dot del R equal to 0. Force is that angle is 90 degrees, so it will go 0. And so now we will see what is virtual work. This got success. So what is that? This virtual displacement. This is virtual displacement. So we will learn about this one. Virtual. What is it? So if you want to write a notes, then this theory of this one I will provide you in next. I will take some photo and provide in next video. So you can write, because now if I write, then till now we did not study about generalized coordinates. So in next video or next to next video we will see generalized coordinates. According them, it will be easy to define and it will be easy to understand. So just now I tell virtual displacement. What is virtual displacement? Virtual displacement over there at t time, means there is no space of time we are not giving. At t time, if any small displacement happen in a system, any very little small, that is called virtual displacement. And if you virtual work, then virtual work is nothing but it is the work done by a virtual displacement. Any force, not applied, I am saying not constant, any force. Random force, if A is n, and if we are taking not this one, and del R this one. So this is virtual work. So these are the things, and if you are working for notes, then we will see next class. So let me continue this one. Explanation, I think, for virtual work and displacement not required, so I am not going. Just I will take video and then CPOC, then photo will take and upload that next week. And the equation which we got here, this equation, you see, for virtual, not for real, virtual, we see this is called the equation is right. Equation or principle. This is called equation. So this is the thing. So now, what when we do it means we have made eventual things. Theoretically, we have imagined that there is some displacement. Why did we do? What are things? So because we removed the force of constant, and if we see, then generally we can say holonomy. If it is whether if it is scleronomy, theonomy, whatever. But we can say that this is force of constant we can remove directly. No need to consider about that force of whatever force of constant is there. For holonomy, we can remove directly. So this is our benefit. But as well as if there is some benefit, then disadvantage will be there also. So if we see in this one, we can write. So in general formula we have that, if you remember that formula, V dot over MA or dP by dt. If you see, we can divide into like this, not divide, means as component we can write that component. So it was more easy, because for here, if you see here, it's a system of particle. Like if I take to 1 to 10 particle, so I have to take each of the particle, then I have to integrate this. So if I take 10 particle, 50 particle, so each and every particle I have to add like this. So this is difficult. But for that one, we can, or each of the particle we could have three component, X component, Y component, Z component, and according that we could have easily solve. And then if you want to know that another one, then I vector, J, I, J, K, we could have. So how to make this easy? So for that one, again we will introduce a new term. What is that? Generalized coordinate. That things we will see in next class. So using that one, we will see the independent coordinate we will make, and we'll see next one is that. So these are the things, and the Alembert equation, the principle we got. So see you in next class. Bye.